Welcome back everyone. In the previous part of this series, I modeled the aluminum extrusions. Now I will use the extrusions to design the frame of the printer. There are many great designs and kits out there, so I will not be reinventing the wheel. I will mostly be taking ideas from these designs to suit my needs. I need my build to achieve the following. It should be Core XY to maximize print quality and speed. The bed should move in the Z-axis. The design should maximize the use of off-the-shelf parts. Sourcing custom parts can be a real pain. It should be scalable to any required size. The most popular choices amongst the Core XY designs are the BLV Cube, Voron and Rat-Rig V-Core, so I will be basing my design on these printers. The BLV uses 2040 extrusions, which should make the frame a lot more rigid. The V-Core also has the option for 3030 extrusions, but it's much easier to source fasteners for the 20 series extrusions. The Voron uses 2020 extrusions, which can compromise rigidity at larger build sizes. The Voron 2.4 belted Z-axis is also complicated to set up. A combination of all these factors led me to design my own printer so I can take what I like from each of the designs and make something unique and tailored to my requirements. I have based the frame of my printer on the BLV Cube because of the 2040 extrusions and easy availability of the metal kit. Using printed parts for the printer mechanics will reduce the rigidity and reliability. The Voron also has a metal kit on AliExpress, but it is a lot more expensive and not as easily available. I did not order the full frame kit for the BLV Cube because I wanted a custom build size and I wanted the design to use standard size extrusions. They are very easily available on AliExpress. Getting back to the design, let's open up Blender and get to work. CAD Transform is a must for this type of work because it makes the aligning process very easy in Blender. I have limited myself to use only two sizes of the extrusions to keep it simple. For my build size, I am going for 500 and 550 mm extrusions. I had already made a mock-up of the design in SketchUp earlier, so you can occasionally see me referring to it. While SketchUp served me well initially, it was a bit limiting as the design progressed and SketchUp itself started lagging, so I made the switch to Blender. Blender is completely free and much more capable, although it does have a bit of a learning curve. I will be using blind joints to connect the extrusions as they need minimal hardware and are much stronger. I just changed the viewport display color as the default was kinda boring. Here you can see that this extrusion needs to be longer. 510 mm to be exact, but as I have limited myself to 500 and 550, I will design a 10 mm spacer. It can be printed, or maybe I will make one on the lathe. You could also pile up a bunch of washers to get the same effect. Now that the initial frame design is complete, I need to bring in the parts from the BLV metal kit. I tried to look for the models or drawings of the metal kit parts, but I did not find anything. So I decided to use the original STL files from the BLV website. The size of the printed parts and the metal kit parts is almost the same, so I can use the STL files as placeholders to proceed further with the design. However, in the final build they will be replaced with the metal kit. Blender makes it very easy to import STL files. The STL files by BLV are already pre-aligned, so I just need to bring in each section, merge it, and align it in its place. I cannot stress enough how useful CAD Transform is for the alignment process, and it is completely free. I would recommend everyone to use it if you will be using Blender for any precision work. I have finished adding in the right and left corners and belt tensioners. The next part is the X-carriage mount, but for that I need to model the linear rails. In the next part I will be doing exactly that, so stay tuned and see you in the next one.